Welcome back, everyone. In this video, we're going to set up a master-slave configuration in MySQL. And this setup is very important because in our next video, we'll integrate this master-slave architecture with Spring Boot. And just a quick note, I'm not an expert in MySQL replication. I'm simply sharing the steps that worked for me. So if I make any mistake or if there's a better way to do something, please do correct me in the comments. I'm always learning, and your feedback helps everyone. Alright, let's get started. Alright, so for this setup I'm using two separate MySQL instances running on two different machines. One MySQL server is running on my Mac, and the second one is running on Linux. In this demo, I'm going to configure the MySQL running on Mac as the master, and the MySQL running on Linux as the slave. This is a real, practical setup, just like you would have in a production environment where databases run on different servers. Before we start editing anything, let's first understand what changes we actually need to make on the master server. Master-slave replication requires a few specific settings, and all of these must be added inside the MySQL configuration file, the my.cnf. So before touching anything, let's quickly look at what needs to be updated in the master config. So the very first step is to check where MySQL is actually reading its configuration from. Different systems load my.cnf from different locations, so we need to verify the exact path on our master machine. To check that, simply run this command on the master server. mysql-help grep my.cnf. This will list all the possible locations where MySQL looks for the my.cnf file. Once we know the correct path, we can open it and start updating the master configuration. Once you run that command, you'll see all the possible locations where my.cnf can exist. If the file already exists in any of those paths, great, you can simply open it and edit it. But if it doesn't exist in any of the locations, no problem, you can just create a new my.cnf file in any valid path from the list. The paths for macOS and Ubuntu were already shown on slide. So on my Mac, I'm going to use the my.cnf file located at /usr/local/mysql/etc/my.cnf. And on my Linux machine, I'll use the file /etc/mysql/mysql.confd/mysqld.cnf. Alright, now inside this config file, we need to add a few important settings for the master. Just copy the exact configuration you see on my screen. Bind address, this allows MySQL to accept connections from other machines. If you set it to 0.0.0.0, it means MySQL will accept connections from any IP address. Server ID, this must be unique for every MySQL server. So the master will have its own ID, and every slave will have a different ID. Log_b, this enables binary logging, which is mandatory for replication because all changes are written to this log. Bin_format, this decides how data changes are recorded in the binary log. The recommended value is row because it logs row-level changes and avoids many replication issues. Binlog_do_db, this is optional. You can specify which database you want to replicate. If you leave it blank, it will replicate all databases. Alright, now let's open our master MySQL server. Okay, before we continue, let's first check the order in which MySQL loads the my.cnf file and from which locations. So I'm going to run the command now, you can see it on my screen. This will list all the locations where MySQL looks for my.cnf. This way we know exactly which file to edit for our master configuration. Alright, I checked all the locations MySQL listed, but there's no my.cnf file anywhere. So no problem, I'm going to create a new my.cnf file myself inside /usr/local/mysql/etc/my.cnf. If you're using Linux, make sure to use the path I showed in the previous slide, usually inside etc/mysql/mysql.confd/mysqld.cnf. So follow along with me. First, I'm going to navigate to that folder using the cd command. Okay, as you can see, there is no etc. folder inside the MySQL directory. No problem, we'll just create it ourselves. And there we go, the folder has been created successfully. Now we can move inside and create our my.cnf file. Let's run the same command as I'm running on my screen. Follow along. The very first thing we need to add inside the my.cnf file is the MySQL section inside square brackets. This tells MySQL that all the settings we're about to write below are specifically for the MySQL server daemon. Next, let's add the bind address. This setting controls which IP addresses are allowed to connect to this MySQL server. If you want to allow only a specific machine to connect, you can put that machine's IP here. But if you want to allow connections from any IP address, which is common for master-slave setups, you can use 0.0.0.0. Next, we need to set the server ID. This value must be unique for every MySQL server in your replication setup. It can be any positive number, 1, 2, 10, 100, anything, as long as no two servers use the same ID. Next, let's add the log_bin setting. This enables binary logging, which is absolutely required for replication because all database changes are stored in this log file. You can give the binary log any name you want, it's just a prefix. MySQL will automatically create files with .0000001, .0000002, etc. Since in this demo I'm going to replicate only the employee_service database, I'm going to name it employee_service bin. Next, we need to set the bin log_format. This setting controls how MySQL records changes inside the binary log. There are three formats: statement, row, and mixed. But for replication, the safest and most reliable one is row. Row mode logs every row level change, which avoids a lot of replication issues and ensures the slave gets the exact same data changes as the master. So I'm going to use row here. Next, we have bin log_do_db. This setting tells MySQL only replicate this specific database. So if you want to replicate only one database from the master to the slave, you can specify it right here. In my case, I want to replicate the employee_service database. Alright, the master configuration is complete. Let's save the file, and we're done with the master's my.cnf setup. Great, now that we've updated the master configuration, the next step is to restart the MySQL server so the changes take effect. Let's restart MySQL, watch on my screen. Alright, MySQL has restarted successfully. Now let's log back into the MySQL client on the master machine. Alright, now that we're logged into the master MySQL server, the next step is to create a special user for replication. This user will be used by the slave machine to connect to the master and read the binary logs. So let's create a new user. I'll call it replication_user. Alright, our replication underscore user has been created successfully. Now the next step is to give this user the proper replication privileges, so the slave can read the master's binary logs. Without these permissions, the slave will not be able to connect or sync data. Great! The replication privileges have been assigned. Now let's run one important command, flush privileges. This forces MySQL to reload all user permissions immediately. Alright, that's done. Our replication user is ready and the master side setup is almost complete. Alright, next we need to run one very important command. Show master status. This command will tell us the current binary log file name and position. And we will need these values when configuring the slave. So let's run it now. Watch on my screen. I'm getting an error when running show master status. And that's actually because this command is supported on older MySQL versions. If you're running an older version of MySQL, show master status will work perfectly. But in the latest MySQL releases, the command has been updated. So instead, you need to use show binary log status. This will give you the same information, the current binary log file and the position, which we need for configuring the slave. Alright, so if the first command didn't work for you, let's run the updated one instead. There we go. As you can see, it returned the binary log file name and the current position. We will need these two values when setting up the slave. So make sure to note them down. Alright, now that the master setup is complete, let's move to the next step, configuring the slave server. Before we configure anything on the slave, let's first test whether the slave machine can actually connect to the master MySQL server. This is super important. If the connection itself doesn't work, replication will definitely fail. So from the slave machine, I'm going to try connecting to the master using the replication underscore user we created earlier. Here, you'll need to enter the IP address of your master machine. I'm not typing my actual IP on the screen for privacy reasons, but you should replace it with your own master server's IP when you run the command. And perfect, as you can see, my slave machine successfully connected to the master MySQL server using the replication user. Now, if you face any issue here, the very first thing you should check is your port. By default, MySQL runs on port 3306, so make sure this port is open and accessible from the slave machine. If the port is blocked, the slave will not be able to connect, no matter how correct your configuration is. So always check the port and firewall settings first. Alright, now let's open the MySQL configuration file on the slave machine. If you're on Linux, run the command I'm showing on the screen to open the mysqld.cnf file. And if you're using macOS as your slave, then run the command I showed earlier in the previous slide to open your my.cnf file. Alright, inside the slave config file, I already have the bind address set, just like we did on the master. This allows external machines, including the master, to communicate with the slave if needed. Next, just like we did on the master, we need to set a server ID here on the slave as well. Remember, every MySQL server in a replication setup must have a unique server ID. Next, we need to set the relay log parameter. The relay log is where the slave stores all the changes it receives from the master before applying them to its own database. You can give it any name you like. MySQL will automatically append numbers to it, just like the binary logs. Next, we need to set the read_only flag on the slave. This is an important setting because it prevents any accidental writes directly on the slave database. Remember, in master-slave replication, only the master should accept write operations, and the slave should only read data that it receives from the master. Next, we'll set the binlog_ format here on the slave as well. Even though the slave typically doesn't write to its own binary logs, it's still recommended to match the master's configuration for consistency and to avoid any unexpected issues. Alright, the slave configuration file is updated. The next step is to restart MySQL and then log into the slave MySQL server. Alright, just to be clear, this terminal is my slave MySQL server, not the master. So now we need to log into the slave MySQL server. Now that we're logged into the slave MySQL server, let's run the replication status command to check the current state before we configure anything. Alright, as you can see, we haven't configured or started replication yet. So the slave status is mostly empty, and that's completely normal. Alright, now we need to run 3 important commands on the slave to set up replication. You can see them on my screen. The first command is stop replica. This simply stops any existing or partial replication process, even if nothing is configured yet. It ensures we're starting with a clean state before applying the new replication settings. Next, we run the main command that actually connects the slave to the master. This is the change replication source to command. And inside this command, we must provide all the details needed for replication. Source_host is simply the IP address of your master machine. So replace it with the actual master server's IP so the slave knows where to connect for replication. Source_user is the replication user we created earlier on the master server. This is the user the slave will use to log into the master and read the binary logs. Source_password is simply the password of that replication user. Make sure to enter the correct password here so the slave can authenticate with the master. Source_log_file is the binary log file name that we got from the master when we ran the show binary log status command. Source_log_file is the exact same file name as shown on my screen. If you remember, we got this by running the command on the master. Show binary log status. So just paste that file name exactly as it appeared on the master. This tells the slave, start replication from this specific binary log file. Next is the source_log_pos. This is the exact position inside the binary log file from where the slave should begin reading. We also got this value from the master when we ran show binary log status. So just copy that position number exactly as it appeared. This tells the slave, start replication from this exact point inside the log file. Once you've replaced all these values, the master IP, replication user, password, log file, and log position, go ahead and run this entire change replication source to command on the slave server. This will configure the slave to connect to the master and start reading its binary logs. And finally, the last command we need to run on the slave is start replica. This command actually starts the replication process. So once everything is configured, just run this command, and your slave will immediately begin connecting to the master and syncing data. Alright, I've executed all the commands on the slave MySQL machine. We stopped the replica, configured the master details, and started replication. Now it's time to verify whether everything is working correctly. So let's run the show replica status \g command again. You can see it on my screen. Alright, my replication still didn't start. I'm getting an error saying GTID is off on the master but on the slave. And since both sides must match, replication won't work like this. GTID replication is a big topic, and I don't want to go deep into it in this video. So to keep things simple and continue our setup, I'm going to disable GTID on the slave so it matches the master. So let's open the slave's mysqld.cnf file again and update the configuration to turn GTID off. Alright, now inside the slave's mysqld.cnf, let's add the line GTID_mode equals off. This turns off GTID on the slave so it matches the master. Let's save the file. And now we need to restart the MySQL server for the changes to take effect. Alright, MySQL has restarted. So now we need to run all the commands again, the same ones you see on my screen. First, stop the replica to reset the state. Then run the change replication source to command again, with the master IP, replication user, password, log file, and log position. And finally, start the replica. Alright, I've run all the commands again. And this time, yes, my replication has finally started successfully. No more errors, the slave is now connected to the master. And the replication process is running exactly as expected. Alright, now let's switch back to the master server. I'm going to log into the master MySQL server again. Let's run one simple command to make sure everything is clean and ready for testing. This ensures that if any tables were locked earlier during binlog reads or configuration, they're now fully unlocked and ready for replication tests. Now I'm going to switch over to dbeaver, the database client I'm using. As you can see, I've already connected to both servers. The master MySQL server with the employee_service database. The slave MySQL server running on Linux. So now let's test whether replication is really working. I'm going to create a new table inside the employee_service database on the master server. Watch on my screen. Alright, the new table is created on the master. Now let's insert some sample data. Alright, so up to this point we've created the table and inserted records on the master server. Alright, now let's switch over to the slave server. Run a select query on the same table. And there it is. The slave MySQL server now contains the new table and the same data we inserted on the master. This confirms that replication is working perfectly. Whatever we do on the master is automatically copied to the slave. Even though we only created the table and inserted the data on the master, the slave picked it up instantly. Alright, let's test it one more time just to be sure everything is syncing correctly. I'm going back to the master database now. And I'm going to insert another new record into the same table. And there it is. The new record we just inserted on the master has instantly appeared on the slave as well. Perfect. Replication is working exactly the way it should. Alright, now let's try the opposite. I'm going to insert a new record directly on the slave database. And let's see what happens. Alright, we can see the new record is inserted on the slave. Now let's switch over to the master and check what happened there. And as you can see, nothing. The record we inserted on the slave did not appear on the master. This is expected, because replication works one way only. Master-slave, not the other way around. So even if the slave allowed the insert, it will not replicate anything back to the master. Now let's check our employee table. The table exists with all the older records on master. And as you can see, there is no table at all on the slave side. But on the master, the table exists with all the older records. So why didn't the slave get that table and the 71 existing rows? That's because MySQL replication does not copy old data automatically. Replication only applies new changes after the replication is started. So if your master already has existing tables and old data, the slave will not get them automatically. To fix this, we need to manually dump the existing data from the master and import it into the slave. Alright, before we dump and import the old data, the first thing we need to do is stop replication on the slave. This ensures that no new events interfere while we are copying the existing data.
So on the slave server, run stop replica.
Now that replication is stopped, the next step is to dump the existing data from the master so we can import it into the slave. I'm going to do this directly from dbeaver. It's super easy. Just right-click on your master database.
Go to Tools, and then select Dump Database.
Next, select the database you want to export, in my case, employee_service. And then select the tables you want to include. You can choose all tables or only specific ones. After selecting, simply click Next to continue.
Watch on my screen. Next, click on Load Client. Next, click on Add Home.
Select the MySQL bin path. This is where your MySQL client tools like MySQL and MySQL dump are located.
Click on Start.
Alright, as you can see, the SQL dump has been successfully created on my machine. Now the next step is to take this dump file and load it into our slave database. Right-click on the slave database in dbeaver.
Go to Tools, Restore Database.
Select your dump file. Browse to the location where we saved the SQL dump earlier.
Click on Start.
Alright, the restore is completed successfully. So now that the data import is done, let's run the second and third commands again on the slave to reconnect it to the master and resume replication.
And perfect.
Replication has started again successfully. Now I'm going back to the master database and inserting a new record into the employee table. Alright, the insert on the master was successful. Now let's jump over to the slave and run select query.
And see.
The new record that we inserted on the master has now appeared on the slave as well. This confirms that replication is working perfectly again. Old data is synced, and new changes are being replicated instantly.
Awesome.
Alright everyone, thank you so much for watching. If this video helped you, don't forget to like, comment, and subscribe. And hit the bell icon so you don't miss the next video. Because in the next video, we're going to take this entire master-slave setup and integrate it directly into a Spring Boot application. See you in the next video.